Okay, so this will be the third video in the series about graphing. So up to this point, the first video, we talked about the rectangular coordinate system. So like what it is, how it works, ordered pairs, how those work. We then talked about just a general introduction to linear equations in two variables. So what they are, what their solutions look like, and how that translates to kind of like the graph of the equation. For this video, it's going to be a little bit shorter, but I did want to do it separately because it's something that it's not really hard, but it keeps coming up as you work throughout graphing. So I wanted it to be its own video so you could easily find it. Okay, so for this video, we're going to talk about horizontal and vertical lines. Okay, so again, it's not going to be a super long video, but it's worth doing kind of separately. Then when I tell you about intercepts and point plotting and slope, the vertical and horizontal lines are going to come back in each of those videos too. Okay, so this is just going to be an overview. Okay, so horizontal and vertical lines. First, I want to remind you of something. So recall from the second video I made, the one where I introduced linear equations in two variables. So recall that a linear equation in two variables is any equation of the form ax plus by equals c, where a, b, and c are real numbers such that a and b are not both 0. Okay, so a linear equation in two variables, a couple of things, you're going to have an x and a y. You know it's linear versus some other type of equation in two variables because the x and the y are raised to the first power. So if I suddenly change that to ax squared plus by equals c, it would no longer be linear. So it's linear because the x and the y are both raised to the first power. They're not squared, they're not cubed, nothing like that. Okay. The coefficient of x and the coefficient of y and that constant c, those are all just going to be real numbers. So that means they could be fractions, they could be decimals, they could be integers, positive, negative, whatever. Okay. The only condition on a and b is that they cannot both be 0. So for this video, let's focus on what happens when either a or b is 0. So what happens when a or b is 0? All right. So let's first look at what happens when b is 0. So what happens when b is 0? Well, we had ax plus by equals c, right? That's just a generic, we call it standard form of a linear equation. So if b was 0, we would get ax plus 0y equals c. Well, generally speaking, when we have something like this, we say that 0y, it kind of cancels out. So we would just end up with ax equals c. So what has happened? Well, when b equals 0, the y term goes away. And I'm going to put goes away in parentheses. It's not like it poof completely disappears. It's just the coefficient of y is now 0. So that 0y term, it just doesn't count anymore. Okay, so the y term goes away, leaving an equation with just x. Okay. So we had this linear equation in two variables. We let the coefficient of y be 0. It makes that term go away. So then you're left with just an equation involving x. Well, fun fact, without a y term, this line can no longer cross the y-axis. Okay. So the way we have these lines, I'm just going to do a quick sketch right here. So let's say we have the Cartesian plane. All right. And we have some line. So this blue is going to be some line. Okay. Well, what that line does is it crosses the X and the Y axis. You can see it crossing the X axis right here and the Y axis right here. Crossing the X axis allows the equation to have an X. Crossing the Y axis allows the equation to have a Y. If I no longer have a Y term, I can no longer cross the Y axis. Okay. So without a Y term, I can't cross the Y axis. And the only way to exist in the Cartesian plane and not touch the Y axis is if I'm parallel to the Y axis. So let's look at what that's going to be like. Okay, so the only way this can happen is if the line is parallel to the y-axis. So no y in the equation means I cannot touch the y-axis, and the only way that can happen with a line in the Cartesian plane is if I'm parallel to the y-axis. So here's the kicker. This means the line is vertical. So let's look at that. All right. Without a y term, we can't touch the y-axis. The only way to live in the Cartesian plane and not touch the y-axis is if the line is vertical. Okay. So when you have an equation that only contains an x, you then have a vertical line. Okay. Now let's look at what happens when a is 0. So what happens when a is 0? Well, we started out with a standard form linear equation in 2 variables. All right. If a is 0, we get 0x plus by equals c. Well, that 0 multiplied by x just makes that term kind of no longer useful to that equation. So just like on the previous slide, when b was 0, the y term goes away, leaving an equation with just x. Well, in this case, when a is 0, the x term goes away. And again, I'm going to use those little air quotes, goes away, leaving an equation with just y. Okay, so if a is 0, the x term goes away, and then I'm left with just an equation containing a y. by equals c. Okay, so this means without an x, the graph cannot cross the x-axis. Okay, so again, no a, so a is 0. It means that there's no x term, leaves an equation with just a y. So now if I have an equation with just a y, I can touch the y-axis, but I cannot touch the x-axis. This means the equation, or the line, I guess is what I should say. This means the line must be parallel to the x-axis. So let's look at what that means. So I've got my Cartesian plane, and I've got a line. It has to be parallel to the x-axis, but still go through the y-axis. That means we have a horizontal line, okay? So this means the line is horizontal. All right, so let's just do a quick recap. So if an equation only has an X, no Y, then the line can only cross the X-axis, not the Y-axis. Therefore, the line is vertical. If an equation only has a Y, no X, then the line can only cross the Y-axis, not the X-axis. Therefore, the line is horizontal. All right. So think about this visually always. If you've got a vertical line, which axis is it crossing? Well, a vertical line is crossing the X-axis. Therefore, the equation has to have an X. If it does not touch the Y-axis, the equation cannot have a Y. The reverse is true. If the line is horizontal, it has to cross the Y-axis. That means the equation has to have a Y. If the equation does not have an X, it cannot touch the X-axis, therefore it's horizontal. So let's look at two really just quick examples. So let's say I have 5x minus 1 equals 9, okay? Notice here, I've got an equation, but there's no Y. If the directions told you to graph this, you would know that you need to graph using the steps that you already understand from graphing equations in two variables. The only issue is you've only got the one variable. So what you do is you solve for the variable that you do have. So solve for the variable that you do have. So I want to get the X alone. First thing I need to do is get the term that contains the X alone. So I'm going to add 1 to both sides. That gives me 5x is 10. I then divide by the coefficient of X. So I have to undo that multiplication of 5 and X. So I undo the multiplication of 5 by division. 5 divided by 5 is 1x. And then 10 divided by 5 is 2. So X equals 2. I have an X. This means I have to cross the X-axis. Therefore, this line is vertical. No Y means I cannot cross the Y-axis. Therefore, I'm vertical. And this tells me right here where I cross the X-axis at. So to graph a vertical line is really quite easy. You draw the Cartesian plane. You look to see what X equals, okay? X equals 2, that ends up being my X-intercept. So this is my X-intercept. It's where I cross the X-axis at. So let's say I've got 1, 2. I draw a point at 2 on the X-axis, and then I simply draw a vertical line through that. All right. Now, if I had to create a table of values, all right, I've got a table of values. That's where you have the X's and the Y's. This would have been something that we talked about in that second video. Well, what value can X be? Well, the only value that X can be is 2. So no matter what ordered pairs you have, the X coordinate's going to be the same. Now, what is Y? Y can literally be anything. So this line, it's a vertical line and it goes on forever. Okay, so Y could be any value. You could have Y equals 0, Y equals -2, or Y equals, let's say, 4. So we get -2, 0, 4. There you have 3 ordered pair solutions to the equation for this vertical line, X equals 2. Let's look at one more example. So let's say we have -3Y minus 12 equals, let's say we have 3, okay? So just like before, we want to solve the equation for the variable that we do have. We do have a y. So let's solve for y. First thing I want to do is isolate the y term. So I need to add 12 to both sides. Those cancel. That leaves me with negative 3y equals 15. And then I want to undo the multiplication of negative 3 and y. So I divide by negative 3. And I end up with y equals negative 5. Well, this tells me where the graph crosses the y-axis. That means this is the y-intercept. Okay. So if I wanted to graph this, we have to sit and think about this for just a minute. I have a y, but I do not have an x. That means I have to touch the y-axis, but I cannot touch the x-axis. Okay. So if I can't touch the x-axis, but I have to touch the y-axis, the only way that works is if I'm parallel to the y-axis. So that makes this a horizontal line. And it is a horizontal line through negative 5 on the y-axis. Now, let's say you did need to create a table of values, no big deal. What value can y be? Well, the only value y could be would be negative 5. And what could x be? X could be anything. This horizontal line goes forever. There's infinitely many x coordinates on this line, so you just have to pick a few. All right, and there you would have ordered pair solutions. So I just arbitrarily chose my x values because this horizontal line, this black line, has infinitely many x coordinates. So like I said, I just arbitrarily chose a few of them, knowing that the y coordinate has to be negative 5. So I got myself 3 ordered pair solutions to this line. I could pick 2 million ordered pair solutions to this line if I wanted to, but those 3 are just a nice little snapshot of what's going on with this equation. Now, that's horizontal and vertical lines. Let's do just a brief recap. Recall that a linear equation in 2 variables is any equation of the form ax plus by equals c, where a, b, and c are real numbers such that a and b are not both 0. A can be 0, b can be 0, just not at the same time. So this video focuses on, well, what happens when my computer's about to die? This focuses on what happens when either A or B is 0. So we looked at the situation of when B is 0. Well, when B is 0, the y term goes away, leaving an equation in just x. What this means is the equation can touch the x-axis, but without a y, cannot touch the y-axis. And the only way for this to happen is if the equation is parallel to the y-axis, which means the line is vertical, okay? Next up, when a is 0, the x term disappears, leaving a y term, okay? So without that x term, when that x term goes away, your graph cannot touch the x-axis. But because the y is there, you still have to touch the y-axis. The only way this can happen is if the line is parallel to the x-axis. This makes the line horizontal, all right? We then looked, we just kind of recapped, and then we looked at an example of a vertical line and how that would look as far as a table of values and the graph. And then we looked at an example of a horizontal line. Okay, so we did vertical lines, horizontal lines. Now, that's it for this video. Okay, so I did this video separately just so you could pretty easily find a video on horizontal and vertical lines. In the next videos that are coming up, we're going to look at intercepts. Horizontal and vertical lines will come up again. We're then going to look at graph by point plotting. We're going to very briefly talk about horizontal and vertical lines there because we kind of talked about it in this video. We're going to talk about slope. When we talk about slope, horizontal and vertical lines are definitely going to come up. When we talk about graphing with a point and a slope, horizontal and vertical lines are going to come back up. When we talk about finding equations of lines, horizontal and vertical lines are going to come back up. So I wanted this just brief introduction video so that when horizontal and vertical lines come up in all the future videos, you'll kind of already know what's going on. All right, so next up, I think I'm going to do a video on intercepts, and then the video after that will be graphing by point plotting. And by the time you're done with intercepts, graphing by point plotting will be pretty easy. All right, so that's it for this one. Good luck. See you in the next video.